So, my product is an automotive intake manifold designed to adapt electronic fuel injection to the Volkswagen Type 4 air-cooled engine. I chose to design the manifold to accept a 2-barrel Holley Sniper EFI throttle body. This is a very economical option compared to purchasing every individual EFI component, not to mention the complexity of programming a custom engine control unit. EFI conversions are desired by automotive enthusiasts because they greatly improve engine performance, efficiency, and reliability. This intake manifold fits a wide variety of applications. From 1968 to 1982, the Type 4 engine was used in 4 different vehicles, including the Porsche 914 and the Volkswagen Type 2 Transporter, like the one behind me. Over the years, the bore and stroke of these engines has changed. Fortunately, the external geometry of the engine was unchanged, therefore my intake manifold can be used on every iteration of the Type 4 engine.
First, I squared all the stock to precise dimensions, making sure to drill half-inch holes in the intake flanges for fixturing purposes. Next, I will machine the intake flanges, but first I must set up the CNC mill. I do this by setting the tool length offset in the CNC controller by using a 1-2-3 block and using the table as a data. Next, I need to fixture the intake flange using half-inch spacers and T-slot bolts. It is important to make sure that the upper edge of the stock is parallel to the machine's x-axis using a dial indicator. To finish the machine setup, I must set the work offsets by using an edge finder to locate the x and y axes of the part, and using a 1-2-3 block to set the z-axis offset. In total, 4 intake flanges must be machined. The intake flanges require a second operation being fixtured in a vise to machine the intake runner holes and bolt holes. For the first operation on the center manifold, I drilled bolt holes that will be tapped and used to secure the throttle body to the manifold. I also machined the bores that align with the 2 throttle plates of the EFI module. For the next operation, I bored 2 more holes along this axis. The purpose of these holes is to remove material from the inside of the manifold since the part is not casted. Unfortunately, I forgot to check if the bolts were tight on the vise, and the workpiece ended up shifting a little during machining. Since I need to seal these bores, I decided to make the bores a little bit bigger at a depth of 1/4 inch from the surface to cover up the severe chatter marks. Next, expansion plugs are installed in the bores with epoxy to ensure that there will be no leaks. For the last 2 machining operations, the intake runner holes and mounting holes are machined. Lastly, I tapped all the small holes so that I can install mounting studs. The intake runners are manufactured by bending 1 5/8 inch by 1/8 inch 6063 aluminum tube to 150 degrees with a 6-inch bend radius. There is extra length left on the tubes so that they can be trimmed to fit between the center manifold and cylinder head on each side. With the tubes bent, I cut the intake runner tubes to fit perfectly between the center manifold and cylinder heads. Next, I use a punch to help secure the tubes on the flanges. Finally, I TIG welded the intake runner tubes onto the flanges, and then completed the final assembly. Here is the finished intake manifold assembly with the EFI module installed. Thanks for watching.